Welcome back, students. We're going to talk about three types of equilibrium calculations. Here's the first type. You're given all concentrations at equilibrium and you find Kc. There's your formula. All entities above at equilibrium have a concentration of 0.01 except water, which is at 0.02. Find Kc. So it's just plug it in and calculate. Okay, here's chemistry. Kc equals concentration of products over reactants. Okay, figured that out. Kc equals CO times water divided by CO2 and H2. There, chemistry's done. Now you're a math student. 0.01, 0.02, plug them in, get 2. Now you're a chemistry student again. What does that mean? That just means it's greater than 1, products are favored. Type 1 is done. That's a type 1 calculation. Easy peasy. Let's look at type 2. This is very easy as well, except you're given Kc this time. Find one unknown concentration. Okay, so you can see our reaction. At equilibrium, the concentration of SO2 and O2 is 0.05. The Kc is 85. There, they gave it to us. Find the concentration of SO3. All right, Kc equals products over reactants. SO3 squared over SO2 squared and times O2. And now I plug in numbers. SO3 is unknown, x, but you got to square it. And 0.05 squared times by 0.05. Okay, now you're a math student, and now you just isolate x, get x by itself. So we'll multiply these to the other side. We'll square root that to get rid of the square root the other side. X equals 0.103. Now let's be careful. Previously, in the previous lesson, we just took out the units. We just said units are going to be different every time, so let's just get rid of moles per liter. This is asking for concentration, so we have to put the units back in now. So this is 0.103 moles per liter. Okay, there you go. There's your answer. And that is how you do type 2. Type 3 is a little different because of the way this is worded. Given the initial concentration and 1 at equilibrium, find Kc. Okay, so the ammonia equation, find Kc when the initial concentration of hydrogen and nitrogen is 1, and the concentration of ammonia gas at equilibrium is 0.2. Voice cracked there. Okay, so initial, we haven't seen that before. Equilibrium, we have seen that. Okay, let's figure this out. So Kc equals products over reactants. Kc equals NH3 squared over N2 times H2 cubed. H2 cubed times N2, okay. All right, now, Kc equals. Kc is an equilibrium constant. The expression is an equilibrium expression. That means you need equilibrium numbers to go into the expression. So when I have initial numbers given to me, I need this thing called an ICE table. Initial, change, equilibrium. Okay, here's the numbers I know right now. They said initial, so I put 1 mole per liter of H2 into this container, okay? And then it's going to start reacting. I put 1 mole per liter of N2 in there. And they told me at equilibrium, I have 0.2 moles of ammonia, okay? Moles per liter of ammonia. So that is my equilibrium number, which goes into my equilibrium expression to find my equilibrium constant. So that number goes there. Okay, that's good. But those numbers are unknown. They didn't give me those. So I don't know those. So I've got to go figure them out. Okay, there's a bunch of question marks on this ICE table. Okay, let's find the question marks and solve this. Okay, we actually already know that number. If you're thinking, you know what that number is already. Remember back to this in the previous lessons? Before the reaction happens, the products aren't there. There's 0 moles per liter. So I know that one. That's 0. Now, if that was 0 and it ends up at equilibrium at 0.2, what does it change by? It was 0. It ends at 0.2. It changed by 0.2. Okay, so that's 0.20 moles per liter. And now I can use that number to find these other two in the change step. Okay, so here's what I do. I take 0.20 moles per liter of ammonia, and then I times it by my unknown. Right now my unknown, I'm going to say, is nitrogen. That's the one I want to find. That's my required. My given is the number I'm using to figure this out, like in stoichiometry. So that's my given number. So I times this by required over given. So required is N2 over given 2 NH3s. So this is where I use my coefficients from my balanced equation. And I think I forgot to put this in, but the NH3s cancel, and I'm left with N2. Anyway, so 0.10 moles per liter of N2. Okay, so that number goes there. All right, now I do the same thing again. Oh, you can only use this stoich portion, this required over given, in the change step because we have to account for some math later. And if you tried to do required over given for initial or equilibrium, you'll miss that math. Okay, so only in this change step. Okay, good. Change category. Okay, next, I'm going to do the same thing again to find the hydrogen's change value. So 0.20 moles per liter times by required 3 H2s over given 2 NH3s. NH3s cancel, which I forgot to put on there, and that gives me 0.3 moles per liter of H2. Okay, and now what math do I use here? Well, remember back to this previous lesson. Look at hydrogen's concentration before when it was initial, and then it dropped to the equilibrium numbers. It went down from 7 to 6 to 5, and iodine went down. The concentration of the reactants is dropping as they slam together and form products. So we're subtracting. It's going down. So I subtract. 1 subtract 0.3 is 0.7. That one's 0.9. And now I finally have my equilibrium numbers to stick into my equilibrium expression to find my equilibrium constant. So there we are. 0.2 divided by 0.7 cubed and 0.9. Figured out I get a Kc of 0.13. And there I have just found my equilibrium constant for this type of question. That is a question that you're going to come across a lot. When you have initials and equilibriums, you got to use an ICE table. So what's the difference between types 1, 2, and 3? Well, types 1 and 2, everything's at equilibrium. Okay, type 3, they're not. You have some initials and some equilibrium numbers. Said another way, type 1, you don't need an ICE table because they've just done all the work for you. You just plug the numbers in. Same with type 2. Don't need an ICE table. You can figure it all out using the expression. But type 3, you got to use ICE to figure out these equilibrium numbers. And once you figure those out, then you can plug it in. Okay. There we are. That concludes my equilibrium lesson. Thank you for watching. See you next time.